Aphorism 36 of Book 2 of the New Organon. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Jeffrey Edwards. The New Organon by Francis Bacon. Translated by James Spedding, Robert Leslie Ellis, and Douglas Denon Heath. Aphorism 36 of Book 2. 36. Among prerogative instances I will put in the 14th place instances of the finger post, borrowing the term from the finger posts which are set up where roads part, to indicate the several directions. These I also call decisive and judicial, and in some cases oracular and commanding instances. I explain them thus. When in the investigation of any nature the understanding is so balanced as to be uncertain to which of two or more natures the cause of the nature in question should be assigned on account of the frequent and ordinary occurrence of many natures, instances of the finger post show the union of one of the natures with the nature in question to be sure and indissoluble, of the other to be varied and separable, and thus the question is decided, and the former nature is admitted as the cause, while the latter is dismissed and rejected. Such instances afford very great light, and are of high authority, the course of interpretation sometimes ending in them and being completed. Sometimes these instances of the finger post meet us accidentally among those already noticed, but for the most part they are new, and are expressly and designedly sought for and applied, and discovered only by earnest and active diligence. For example, let the nature in question be the ebb and flow of the sea, each of which is repeated twice a day and takes 6 hours each time, subject to some slight difference which coincides with the motion of the moon. The following will be a case of the parting of the roads. This motion must necessarily be caused either by the advance and retreat of the waters, as water shaken in a basin leaves one side when it washes the other, or else by a lifting up of the waters from the bottom and falling again, as water in boiling rises and falls. The question is to which of these two causes the ebb and flow should be assigned. Now, if we take the first, it follows that when there is a flood on one side of the sea, there must be at the same time an ebb somewhere on the other. To this point therefore the inquiry is brought. Now it has been observed by Acosta and others, after careful research, that on the shores of Florida, and the opposite shores of Spain and Africa, the floods take place at the same time, and the ebbs take place at the same time also, and not that there is an ebb from the shores of Spain and Africa when there is a flood on the shores of Florida. And yet, if you look at it more closely, this does not prove the case in favour of the rising and against the progressive motion, for waters may move in progression, and yet rise upon the opposite shores of the same channel at the same time, as when they are thrust together and driven on from some other quarter. For so it is with rivers, which rise and fall on both banks at the same hour, and yet that motion is clearly one of progression, namely, of the waters entering the mouth of the rivers from the sea. It may therefore happen in a like manner that waters coming in a vast mass from the East India Ocean are driven together and pushed into the channel of the Atlantic, and on that account flood both sides at once. We must inquire therefore whether there be any other channel in which the water can be retreating and ebbing at the same time, and we have the South Sea, a sea at least as wide, indeed wider and larger than the Atlantic, which is sufficient for the purpose. At length, then, we have come to an instance of the finger post in this case, and it is this. If we find for certain that when there is a flood on the opposite coasts of Florida and Spain in the Atlantic, there is also a flood on the coast of Peru and the back of China in the South Sea, then indeed on the authority of this decisive instance we must reject the assertion that the ebb and flow of the sea, which is the thing inquired into, takes place by a progressive motion, for there is no sea or place left in which the retreat or ebbing can be going on at the same time. And this may be most conveniently ascertained by asking the inhabitants of Panama and Lima, where the two oceans, the Atlantic and Pacific, are separated by a small isthmus, whether the ebb and flow of the sea takes place on the opposite side of the isthmus at the same time, or contrariwise, when it is ebbing on one side it is flowing on the other. Now this decision or rejection appears to be certain, if we take it for granted that the earth is immovable, but if the earth revolves, it is perhaps possible that in consequence of the unequal rotation, in point of speed, of the earth and the waters of the sea, the waters are violently driven upwards into a heap, which is the flood, and, when they can bear no more piling, release and let down again, which is the ebb. But on this inquiry should be made separately. Still, even on this hypothesis, our position remains equally fixed, that there must of necessity be an ebb of the sea going on in some parts, at the same time that a flood is going on in others. Again, let the nature in question be the latter of the two motions we have supposed, namely, the rising and sinking motion, if on careful examination we reject the former motion of which I spoke, the progressive. With regard to this nature, the road branches into three. For the motion by which the waters rise in the flood and sink in the ebb, without any accession of other waters rolling in, must necessarily be brought about in one of these three ways. Either there is an accession of water pouring out from the interior of the earth, and again retreating into it, or there is no accession to the mass of water, but the same waters, without increase of quantity, are extended or rarefied so as to occupy a greater space and dimension, and again contract themselves, or there is no increase either of supply or extension, but the same waters, the same in quantity as in density, are raised by some magnetic force attracting them from above, and by consent therewith, and then fall back again. Let us now dismiss the two former causes of motion, and reduce our inquiry to the last, that is to say, let us inquire whether any such raising by consent or magnetic force may happen. Now, in the first place it is evident that the waters, as they lie in the trench or hollow of the sea, cannot all be raised at once, for want of something to take their place at the bottom, so that even if there were in water any such desire to rise, it would be barred and checked by the cohesion of things, or, as it is commonly called, the abhorrence of a vacuum. It remains that the waters must be raised in one part, and thereby be diminished and retreat in another. Again, it will follow of necessity that the magnetic force, since it cannot act upon the whole, will act with the greatest intensity on the middle, so as to raise up the water in the middle, upon which the rest must follow, and fall away on the sides. Thus at length we come to an instance of the finger post on this subject. For if we find that in the ebb of the sea the surface of the water is more arched and round, the waters rising in the middle of the sea and falling away from the sides, that is, the shores, and that in the flood the same surface is more even and level, the waters returning to their former position, then indeed on the authority of this decisive instance the raising by magnetic force may be admitted, otherwise it must be utterly rejected, and this would not be difficult to ascertain by trial in straits, with sounding lines, viz., whether during ebbs the sea be not higher or deeper toward the middle than during floods. It is to be observed, however, that, if this be the case, the waters must, contrary to the common opinion, rise in ebbs and sink in floods, so as to clothe and wash the shores. Again, let the nature investigated be the spontaneous motion of rotation, and in particular whether the diurnal motion whereby to our eyes the sun and stars rise and set, be a real motion of rotation in the heavenly bodies, or a motion apparent in the heavenly bodies and real in the earth. We may here take for an instance of the finger post the following. If there be found in the ocean any motion from east to west, however weak and languid, if the same motion be found a little quicker in the air, especially within the tropics, where because of the larger circles it is more perceptible, if the same motion be found in the lower comets, but now lively and vigorous, if the same motion be found in planets, but so distributed and graduated that the nearer a planet is to the earth its motion is slower, the further a planet is distant from the earth its motion is quicker, and quickest of all in the starry sphere, then indeed we should receive the diurnal motion as real in the heavens, and deny such motion to the earth, because it will be manifest that motion from east to west is perfectly cosmical, and by consent of the universe, being more rapid in the highest parts of the heavens, and gradually falling off, and finally stopping and becoming extinct in the immovable, that is, the earth. Again, let the nature in question be that other motion of rotation so much talked of by philosophers, the resistant and contrary motion to the diurnal, viz., from west to east, which old philosophers attribute to the planets, also to the starry sphere, but Copernicus and his followers to the earth as well. And let us inquire whether any such motion be found in nature, or whether it be not rather a thing invented and supposed for the abbreviation and convenience of calculation, and for the sake of that pretty notion of explaining celestial motions by perfect circles. For this motion in the heavens is by no means proved to be true and real, either by the failing of a planet to return to its diurnal motion to the same point of the starry sphere, or by this, that the poles of the zodiac differ from the poles of the world, to which two things we owe this idea of motion. For the first phenomena is well accounted for by supposing that the fixed stars outrun the planets and leave them behind. The second, by supposing a motion in spiral lines, so that the inequality of return and the declination to the tropics may rather be modifications of the one diurnal motion than motions contrary or around different poles. And most certain it is, if one may but play the plain man for a moment, dismissing the fancies of astronomers and schoolmen, whose way it is to overrule the senses, often without reason, and to prefer what is obscure, that this motion does actually appear to the senses such as I have described, for I once had a machine made with iron wires to represent it. The following would be an instance of the finger post on this subject, if it be found in any history worthy of credit that there has been any comet, whether high or low, which has not revolved in manifest agreement, however irregular, with the diurnal motion, but has revolved in the opposite direction. And certainly we may set down thus much as established, that there may be in nature some such motion. But if nothing of the kind can be found, it must be regarded as questionable, and recourse be had to other instances of the finger post about it. Again, let the nature in question be weight or heaviness. Here the road will branch into two, thus. It must needs be that heavy and weighty bodies either tend of their own nature to the centre of the earth, by reason of their proper configuration, or else that they are attracted by the mass and body of the earth itself as by the congregation of kindred substances, and moved to it by sympathy. If the latter of these be the cause, it follows that the nearer heavy bodies approach to the earth, the more rapid and violent is their motion to it, and that the further they are from the earth, the feebler and more tardy is their motion, as is the case with magnetic attraction, and that this action is confined to certain limits, so that if they were removed to such a distance from the earth that the earth's virtue could not act upon them, they would remain suspended like the earth itself, and not fall at all. With regard to this, then, the following would be an instance of the finger post. Take a clock moved by leaden weights, and another moved by the compression of an iron spring. Let them be exactly adjusted, that one go not faster or slower than the other. Then place the clock moving by weights on top of a very high steeple, keeping the other down below, and observe carefully whether the clock on the steeple goes more slowly than it did on account of the diminished virtue of its weights. Repeat the experiment in the bottom of a mine, sunk to a great depth below the ground. That is, observe whether the clock so placed does not go faster than it did on account of the increased virtue of its weights. If the virtue of the weights is found to be diminished on the steeple and increased in the mine, then we may take the attraction of the mass of the earth as the cause of weight. Again, let the nature investigated be the polarity of the iron needle when touched with the magnet. With regard to this nature the road will branch into two, thus. Either the touch of the magnet of itself invests the iron with polarity to the north and south, or it simply excites and prepares the iron, while the actual motion is communicated by the presence of the earth, as Gilbert thinks, and labours so strenuously to prove. To this point therefore tend the observations which he has collected with great sagacity and industry. One is, that an iron nail which has lain for a long time in a direction between north and south gathers polarity, without the touch of the magnet, by its long continuance in this position, as if the earth itself, which on account of the distance acts but feebly, the surface or outer crust of the earth being destitute, as he insists, of magnetic power, were yet able by this long continuance to supply the touch of the magnet and excite the iron, and then shape and turn it when excited. Another is, that if iron that has been heated white hot be, while cooling, laid lengthwise between north and south, it also acquires polarity without the touch of the magnet, as if the parts of the iron, set in motion by ignition and afterwards recovering themselves, were at the very moment of cooling more susceptible and sensitive to the virtue emanating from the earth than at other times, and thus became excited by it. But these things, though well observed, do not quite prove what he asserts. Now with regard to this question, an instance of the finger post would be the following. Take a magnetic globe, and mark its poles, and set the poles of the globe towards the east and west, not towards the north and south, and let them remain so. Then place at the top an untouched iron needle, and allow it to remain in the position for 6 or 7 days. The needle, while over the magnet, for on this point there is no dispute, will leave the poles of the earth and turn toward the poles of the magnet, and therefore as long as it remains thus, it points east and west. Now if it be found that the needle, on being removed from the magnet and placed on a pivot, either starts off at once to the north and south, or gradually turns in that direction, then the presence of the earth must be admitted as the cause. But if it either points as before east and west, or loses its polarity, this cause must be regarded as questionable, and further inquiry must be made. Again, let the nature in question be the corporeal substance of the moon. That is, let us inquire whether it be rare, consisting of flame or air, as most of the old philosophers opined, or dense and solid, as Gilbert and many moderns, with some ancients, maintain. The reason for the latter opinion rests chiefly on this, that the moon reflects the rays of the sun, nor does light seem to be reflected except by solid bodies. Therefore instances of the finger post on this question will, if any, be those which prove that reflection may take place from a rare body, as flame, provided it be of sufficient denseness. Certainly, one cause of twilight among others is the reflection of the rays of the sun from the upper part of the air. Likewise we occasionally see rays of the sun in fine evenings reflected from the fringes of dewy clouds with a splendour not inferior to that reflected from the body of the moon, but brighter and more gorgeous, and yet there is no proof that these clouds have coalesced into a dense body of water. Also, we observe that the dark air behind a window at night reflects the light of a candle, just as a dense body would. We should also try the experiment of allowing the sun's rays to shine through a hole on some dusky bluish flame. For indeed, the open rays of the sun, falling on the duller kinds of flame, appear to deaden them so that they seem more like white smoke than flame. These are what occur to me at present as instances of the finger post, with reference to this question. And better may perhaps be found. But it should always be observed that reflection from flame is not to be expected, except from a flame of some depth, for otherwise it borders on transparency. This however may be set down as certain, that light on an even body is always either received and transmitted, or reflected. Again, let the nature in question be the motion of projectiles, darts, arrows, balls, etc., through the air. This motion the schoolmen, as their way is, explain in a very careless manner, thinking it enough to call it a violent motion as distinguished from what they call a natural motion, and to account for the first percussion or impulse by the axiom that two bodies cannot occupy the same place on account of the impenetrability of matter, and not troubling themselves at all how the motion proceeds afterwards. But with reference to this inquiry the road branches into two in this way. Either this motion is caused by the air carrying the projected body and collecting behind it, as the stream in the case of a boat, or the wind in that of straws, or it is caused by the parts of the body itself not enduring the impression, but pushing forward in succession to relieve themselves from it. The former of these explanations is adopted by Fracastorius, and almost all who have entered into the investigation with any subtlety, and there is no doubt that the air has something to do with it. But the other notion is undoubtedly the true one, as is shown by countless experiments. Among others, the following would be an instance of the finger post on this subject, that a thin iron plate, or a stiffish iron wire, or even a reed, or a pen split in half, when pressed into a curve between the finger and thumb, leaps away. For it is obvious that this motion cannot be imputed to the air gathering behind the body, because the source of motion is in the middle of the plate or reed, not in the extremities. Again, let the nature in question be the rapid and powerful motion of the expansion of gunpowder into flame, by which such vast masses are upheaved, such great weights discharged, as we see in mines and mortars. With respect to this nature the road branches into two in this way. The motion is excited either by the mere desire of the body to expand when set on fire, or partly by that and partly by the desire of the crude spirit in the body, which flies rapidly away from the fire, and bursts violently from its embrace as from a prison house. The schoolmen and common opinion deal only with the former desire, for men fancy themselves very fine philosophers, when they assert that the flame is endowed by its elementary form with a necessity of occupying a larger space than the body had filled when in the form of powder, and that hence the motion ensues. Meanwhile, they forget to notice that although this be true on the supposition that flame is generated, it is yet possible from the generation of flame to be hindered by a mass of matter sufficient to suppress and choke it, so that the case is not reduced to the necessity they insist on, for that expansion must necessarily take place, and that there must needs follow thereon a discharge or removal of the opposing body, if flame be generated, they rightly judge. But this necessity is altogether avoided if the solid mass suppress the flame before it be generated, and we see that flame, especially in its first generation, is soft and gentle, and requires a hollow space wherein to play and try its strength. Such violence therefore cannot be attributed to flame by itself, but the fact is that the generation of these windy flames, or fiery winds as they may be called, arises from a conflict of two bodies of exactly opposite natures, the one being highly inflammable, which is the nature of sulphur, and the other abhorring flame, as the crude spirit in nitre, so that there ensues a strange conflict, the sulphur kindling into flame with all its might. For the third party, the willow charcoal, does no more than incorporate and combine the other two, while the spirit of nitre bursts forth with all its might, and at the same time dilates itself, as air, water, and all crude bodies do when affected by heat, and thus flying and bursting out fans meanwhile the flame of the sulphur on all sides, as with hidden bellows. On this subject we may have instances of the finger post of two kinds. The first, of those bodies which are most highly inflammable, as sulphur, camphor, naphtha, and the like, with their compounds, which catch fire more quickly and easily than gunpowder, if not impeded, from which it appears that the desire of bursting into flame does not produce by itself that stupendous effect. The other, of those bodies which shun and abhor flame, as all salts. For we find that if salts are thrown into the fire, their aqueous spirit bursts out with a crackling noise before flame is caught, which is the case also, though in a milder degree, with the stiffer kinds of leaves, the aqueous part escaping before the oily catches fire. But this is best seen in quicksilver, which is not inaptly called mineral water, for quicksilver, without bursting into flame, by mere eruption and expansion almost equals the force of gunpowder, and is also said, when mixed with gunpowder, to increase its strength. Again, let the nature in question be the transitory nature of flame, and its instantaneous extinction. For the nature of flame appears to have no fixed consistency here with us, to be every moment generated and every moment extinguished. For it is clear that in flames which continue and last, the continuance we see is not of the same individual flame, but is caused by a succession of new flame, regularly generated. Nor does the flame remain numerically identical, as is easily seen from this, that if the food or fuel of flame be taken away, the flame instantly goes out. With reference to this nature, the roads branch into two. Thus, the instantaneous nature proceeds either from a cessation of the cause which at first produced the flame, as in light, sound, and the motion called violent, or from this, that the flame, though able by its own nature to remain with us, suffers violence and is destroyed by the contrary natures that surround it. On this subject therefore we may take the following as an instance of the finger post. We see in large fires how high the flames ascend, for the broader the base of the flame, the higher is its vertex. Thus extinction appears to commence at the sides, where the flame is compressed and troubled by the air. But the heart of the flame, which is not touched by the air, but surrounded by other flames on all sides, remains numerically identical, nor is it extinguished until gradually compressed by the surrounding air. Thus all flame is in the form of a pyramid, being broader at the base where the fuel is, but sharp at the vertex where the air is antagonistic and fuel is wanting. But smoke is narrow at the base and grows broader as it ascends, like an inverted pyramid, the reason being that the air admits smoke and compresses flame. For let no one dream that lighted flame is air, when in fact they are substances quite heterogeneous. But we may have an instance of the finger post more nicely adapted to this purpose, if the thing can be made manifest with bi-coloured lights. Fix a lighted wax taper in a small metal stand. Place the stand in the middle of a bowl, and pour round it spirit of wine, but not enough to reach the top of the stand. Then set fire to the spirit of wine. The spirit of wine will yield a bluish, the taper a yellow flame. Observe therefore whether the flame of the taper, which is easily distinguished by its colour from the flame of the spirit of wine, since flames do not mix at once, as liquids do, remains in a conical or rather tends to a globular form, now that there is nothing to destroy or compress it. If the latter is found to be the case, it may be set down as certain that flame remains numerically identical as long as it is enclosed with other flames and feels not the antagonistic action of the air. Let this suffice for instances of the finger post. I have dwelt on them at some length to the end that men may gradually learn and accustom themselves to judge of nature by instances of the finger post and experiments of light, and not by probable reasonings. End of Aphorism 36 of Book 2. Recording by Geoffrey Edwards.